Assalamualaikum, I will to my dear lecturer, Miss Nur Shafika binti Idris. My name is Aina Dinda binti Muhammad Fandi. From Kuliah 16, me and my group mates, Ifan, Shaza and Hafizah, group 9, we are going to present about our topic, which is titanium trichloride as catalyst. So what is titanium? Titanium is not a rare element. It is the ninth most abundant element. Its abundance is estimated to be about 0.63%. It is right between hydrogen and potassium for element abundance on Earth. The properties of titanium. For the physical properties, titanium exists as dark gray metal or powder. It is brittle at low temperature and can easily be broken at room temperature. Titanium also malleable and ductile at high temperature. The melting point for titanium is 1677 degrees Celsius. The boiling point is 3277 degrees Celsius, and the density for titanium is 4.6 grams per centimeter cube. For the chemical properties, titanium is quite unreactive. It doesn't react with the air at room temperature, acid, chloride, and any other corrosive chemicals. However, the reactivity increases at high temperature. It reacts with oxygen when heated enough. So we will proceed with the next slide. Thank you.
Assalamualaikum. Hi, my name is Muhammad Ifam Yusufian. Today I would like to share, I will present to you guys about titanium trichloride. So this is a physical look of titanium trichloride. It's look like violet, purplish. So basically this is a lower structure of TiCl3. Basically, the electronic geometry for TiCl3 is trigonal planar. So this is some of properties of titanium trichloride. So the molecular formula for titanium trichloride is TiCl3. So and density, its density is 1.22 gram over milliliter, and it reacts violently in H2O, which is water. So its storage temperature in ambient temperature. So next is titanium trichloride as catalyst. So one of the most important is trichloride, TSCl3, a crystalline form of which is particularly useful as a catalyst in the specific polymerization of propylene to make the commercially valuable polypropylene. So basically, most of time, titanium trichloride is used to uh, make polymer, which is polypropylene. So basically, polypropylene is used to make plastic plastic bottle, plastic bottle, plastic cup, plastic bowl, and something else. So addition polymerization usually are carried out in the presence of catalyst, which is certain cases exert control over structural details that have important effect on the properties of the polymer. So basically, titanium trichloride basically give some effect to the product, which is the polymer. So I hope you guys can understand what I'm talking about. So that's all for me. Thank you.
Hello everyone, my name is Saidi, and now I would like to continue with the Ziglenata catalyst, which is actually related with the main topic today, which is titanium trichloride as a catalyst. So before I start, I would like to share the details about how it is called as Ziglenata catalyst. Back in 1950, the German chemist named Carl Ziegler has originated this catalyst for the polymerization of ethylene at atmosphere pressure. Ziegler has employed a catalyst consisting of a mixture of titanium tetrachloride and also an alkyl derivative of aluminum. However, this method has been extended by an Italian chemist named Giuliano to the other olefins and developed further variations of the Ziegler catalyst based on his finding on the mechanism of the polymerization reaction. So the Ziegler-Natta catalyst mixture of halides of the Ziegler-Natta catalyst include many mixtures of halides of transition metals, especially titanium, chromium, vanadium, and zirconium with organic derivative of non-transition metals, particularly alkyl aluminum compounds. So this is how the name Ziegler catalyst is exists nowadays. So nowadays they use the method that has been extended by the Giulio Natta. So the Ziegler Natta catalyst is any of an important class of mixtures of chemical compounds remarkable for their ability to effect the polymerization of olefins, which is the hydrocarbons containing a double carbon-carbon bond to produce polymers of high molecular weights and highly ordered stereoregular structures. Alright, now we will continue with this diagram, which is the Ziegler-Natta catalyst that is involved in the polymerization process of the ethylene. So polymerization is a process that produces a very large chain-like or network molecules that is called as polymers, and the ethylene is one of the alkenes that is called CH2. Alright, so up here we have the slurry composition. Slurry composition, that means a semi-liquid mixture. And we have here P as polyethylene, E as unreacted ethylene, C Ziegler-Natta catalyst as solvent, and W for water. Alright, so this process actually begins with the ethylene gas here is pumped up through the reaction vessel under the atmospheric pressure. So it is polymerizes in this reactor with the under the influences of this catalyst and also with the presence of the solvent here. Alright, so when it is mixed up together, slurry composition is exit out from the reactor, which is the polyethylene, unreacted ethylene, catalyst, and also the solvent. So here we can see that this unreacted ethylene, unreacted ethylene here is separated and returned back to the reactor here to be used for the next cycle. So now we left with the other slurry composition, which is here we can see the polyethylene catalyst and also the solvent. So here the catalyst will be neutralized by the alcohol, which is we have here, for example, methanol, and be filtered out from the filter to become the activated catalyst. So now we have left composition, which is polyethylene and also solvent here, and then it is the excess solvent here will be recovered from the hot water bath and be recycled for the next process or cycle of this process. Here it will be sent back to the solvent tank here. Alright. So the composition left is only polyethylene with water, and it is the dryer here will be dehydrates the wet polyethylene so that it become the dried polyethylene here, which is in the it is final powder form. So this is actually how the ethylene is produced under the process of polymerization with the presence of Ziegler-Natta catalyst. So this is actually how the titanium trichloride also involved in the catalyst as a catalyst.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurushaza Imam binti Muhammad Murad, and I will be explaining about current development of titanium trichloride. Titanium trichloride catalyzed one-pot protocol for the conversion of aldehydes into 5-substitute 1H tetrazole. A one-pot synthesis is a strategy to improve the efficiency of a chemical reaction whereby a reactant is subjected to successive chemical reactions in just one reactor. It is used because of shorter reaction time, easy reaction setup, and inexpensive, reusable catalyst easily separable by simple filtration. So this is the chemical equation for one-pot synthesis. RCHO, which is aldehyde, plus NH2OH, which is hydroxylamine, plus NaN3, sodium azide, with the addition of titanium trichloride and DMF, dimethylformamide, with under reflux condition forming 5-substitute 1H tetrazole. Okay, so we have reached the end for this topic. So this is our references. That's all from us. Thank you.